So we will be starting with the introduction to blockchain, followed by blockchain type, public blockchain and private blockchain. Then we will be discussing in brief about consensus mechanism, because you must have already discussed in the previous sessions. Then we have few blockchain design principles, different attacks and their solution. Then we'll discuss few about miners, and finally we'll discuss the application of permission blockchain. So let's begin with the introduction to blockchain. So as you may be already aware that blockchain, it consists of several existing technologies. It is nothing like that. This is being developed from scratch. So blockchain is not developed from scratch. It is just an integration of existing technologies. And I will show you a couple of slides where you will get to know how blockchain evolves gradually. It's a gradual evolution of blockchain. So as per the definition, a blockchain is an open distributed ledger that can record transaction between two parties efficiently and in verifiable and permanent way without the need of central authority. So dear participants, if I want to ask you that you take away some few keywords from this definition. So what will be the keywords after reading this definition that will come to your mind or that will click to your mind? So I expect central authority, then I expect distributed ledger, then I expect this word permanent. So when you say without the need for a central authority, this means that there is no single point of failure. So you must have heard of client server models and other peer-to-peer models, which we are going to discuss in the upcoming slides. So this is something decentralized. So we are doing everything here without depending on a single entity. So it's completely decentralized and there is no involvement of a single body or single entity, no dependency on a single entity. Then the second takeaway is permanent. Permanent is something that cannot be changed. And in case of blockchain, if someone tries to manipulate the things or tamper the blockchain, so it will readily get invalidated. So it's not that much easy to manipulate the things here in blockchain. And it is a distributed ledger. So distributed ledger is again something when there is not no dependency on a single entity, things are distributed, things are delegated, and we can access them anywhere and anytime. So it's an open distributed ledger that record transactions between two parties efficiently and in verifiable and permanent way without the need for a central authority. So currently we have a bank as the middleman who takes care of all the transactions that are taking place today when two parties are working on some transaction or communicating with each other. So we'll discuss more on this one in the upcoming slides. So there are a few characteristics that needs to be remembered. First one is open, so anyone can access the blockchain. Next is distributed or decentralized, so not under the control of single authority. It is efficient, that is, it means that it is fast and it can be scaled as per the user requirement. Verifiable, everyone can check the validity of information because each node maintains a copy of the transaction. So it is verifiable and we can verify the transaction over the blockchain. And it is permanent. So once the transaction is done, it is persistent and can't be altered. So means if someone tries to alter the transaction or someone tries to manipulate the things that has already happened, so if it is so the blockchain will get invalidated, and it is not easy to manipulate the things that has already taken place, or that are being captured by the blockchain. So this is a client server model, and you all must be very much familiar with this model. So it is a traditional client server model. So here we used to have one server, and this server is responsible for rendering the services to different devices like laptop, personal computer, edge device, smartphones, and other things. So here, participants, you can see the dependency is totally on this server. If this server stops working or this server somehow shuts down, so everything will come to halt. This laptop, this smartphone, and this personal computer, whatever services are being rendered by this server, so this server is no more accessible. So this server is no more accessible. So this is what we mean by single point of failure or central authority. So these things should not exist, because these days we are heavily using technologies in our day-to-day life. We are knowingly or unknowingly using cloud services in some way or other. Even if we are using Gmail, then also we are accessing the cloud services. If we are using Google Drive, then also we are accessing the cloud services. So anything which is available to us 24 cross 7, anytime, anywhere. So it is somewhere that we are using cloud services. So this is a traditional client server model, which you can easily see the dependency is there, and this should not be there in the distributed system or decentralized system. So so in the centralized system, we have a core authority that dictates the truth to the other participant in the network. Only privileged user or institution can access the history of transaction and or confirm the new transaction. So this is a kind of centralized network where all the users are connected to a centralized authority or centralized server, and they will get the required services from this centralized server only. So in case of decentralized system, what we have done, we have delegated the powers, or we have delegated the resources, and there is no centralized authority. All users can render the services, and all users can access the services as required by them. So it is a decentralized server, and they have no core authority to dictate the truth to the other participant in the network. Every participant in the network can access the history of transaction and confirm the new transaction. So there is no single point of failure. There is no centralized authority here in this case in decentralized system. So every user can act as a service provider, and every user can act as a service requester. So in traditional centralized server, we used to have central server, and all other user they need to request to this central servers to get the services. So it is quite slow. There is single point of failure, and high bandwidth uses for server is required. But in case of decentralized peer-to-peer system, it is very fast. There is no single point of failure, and all users, they can also act as a service provider and service requester at the same time. So in case of decentralized system, even if some of the nodes gets down, So there won't be any effect on the system. System will keep running. So this is the biggest advantage of decentralized system. So it never comes to halt because we have other service providers who can render the same set of services as requested by the user. So if one, even if one server is down, user can start accessing or getting the services from the different server whosoever is capable of providing the same set of services. So this is something decentralized peer-to-peer system, and this is what we use in blockchain technology. So in blockchain, as it clears from the name, it is a chain of blocks. So it is quite important for you to understand what exactly a block is, how it looks like, what is the structure of that block. So blockchain starts with a block called Genesis block. So the first block in the blockchain is called as Genesis block. I will discuss the properties of Genesis block in the next slide. Because it is the first block in the blockchain, so it is called as Genesis block. Each block stores the following information in it. Index, that is the position of the block in blockchain. Index of Genesis block is 0. Because Genesis block is the first block, so its index will be 0. And for the remaining blocks, it contains the position of that block in the blockchain. Then here we have timestamp. So it is something the time when that particular block was created. So at what time that block is created, and so this is being stored by timestamp. Then we have hash. So it is a numeric value that uniquely identify data, just like our fingerprints. So hash you must be aware of. So here this hash is it uniquely identifies that block, and block is identified this, or it can be searched, or it can be uniquely identified with this hash value, because hash is a unique value for every block. Then previous hash, this is very important, previous hash, and I will let you know the significance of this one. So hash value of the previous block, so this stores the hash value for the previous block, and for Genesis block this value is 0, because Genesis block is the first block in the blockchain. So the value of previous hash will be 0, and for the other blocks it will contain the hash value of the previous blocks. Data, so data is stored on the node, for example transactions. So it will contain the information about the transactions, what transactions are being done on the blockchain, and in what context it is being done, like land revenue, like voting, like healthcare. So because in every domain the attributes will change, and some are static and some are dynamic. So accordingly it will store the data. Then we have a nonce. So it is a number used to find the valid hash. To generate this number, the processing power is used. So it is used to find the valid hash, and it is generated with the help of processing power. Then we have a Genesis block. So as discussed in the previous slide, so this Genesis block is the first block in the blockchain, and because it is the first block in the blockchain's index position is 0, and the value in this previous hash is also 0, because it is the first block, so there does not exist any previous block for this one, so this value is 0. Then as we have discussed in the previous slide, it will contain the timestamp. The timestamp, it will contain the time at which this block is created. Then it will contain some data. Then it will contain the hash value of this block. Then it will contain the nonce that again uniquely identify this block. So these are the attributes of the Genesis block. The only difference is that the value in the previous hash block will be 0, as it does not have any previous block in for this one. Then we have blockchain mechanism. So blockchain works like a public ledger. Any small change in the data value can affect the hash value, hence affecting the whole blockchain. Every peer in the blockchain network maintains a local copy of the blockchain. All the replicas need to be updated with the last mined block, and all the replicas need to be consistent. The copies of the blockchain at different peers need to be exactly similar. Now, dear participants, the second point says that any small change in the data value can affect the hash value. So this means that block has a hash value and block has some attributes. So depending on those attributes, its hash will be calculated or generated. So if there is any change in those values, so the hash value will get changed. So this will affect the whole blockchain. So a new hash will be generated. So every peer in the blockchain maintains a local copy of the blockchain. So all the peers who are participating in the blockchain will maintain a copy of blockchain. So these copies are known as replicas. So whenever the replicas are involved here, so a issue that get associated with replica is consistency. Consistency is one issue that automatically get associated whenever replicas are being created for any blockchain or for any logical file. So blockchain is nothing but a logical file only. So this issue of consistency needs to be maintained, and it is quite critical issue that how frequently the blockchain is getting updated, and do we need to communicate those changes immediately, or we can communicate those changes on demand, or we can do lazy updation of blockchain. So again, this is a topic of research, how we are updating the or maintaining the consistency of the blockchain, and how frequently the blockchain is being updated or being changed. So as and when the blockchain will get update or blockchain will get changed, those changes need to be communicated to all the replicas on the local miner or on the local copy wherever it is available, because we cannot work with the stale or outdated blockchain. If we keep on working with the stale or outdated blockchain, we will keep getting wrong results. So either we need to set a flag on the replica of a blockchain to ensure that, or to inform that the blockchain has been modified, and before start working on this blockchain, we need to get a updated copy of this blockchain. So whenever replicas are being created, the issue of consistency gets automatically associated with some logical file. So as you know, this is nothing but a logical file chain of logical files only. So this issue of consistency needs to be considered, and it needs to be tackled very wisely, because uh, if it is not handled very quite wisely, so it may create overhead, and issue of congestion can creep in. So it should not be like this, that we are if blockchain is modifying very frequently, every time we are performing the updates, so it can create the overhead, because on the same blockchain other transactions, other operations are parallelly happening. So that needs to be considered. So This is how a transaction is taking place in a blockchain. So let's assume that we have two parties that needs to perform a transaction for anything. It can be a healthcare system, it can be a land revenue, it can be a voting or something like that. So someone requests a transaction. Suppose two commodities are being communicating with each other, and yet the transaction needs to be performed. So the requested transaction is broadcast to a peer-to-peer network consisting of computer known as nodes. So it will be broadcasted, and peer-to-peer network of nodes validate the transaction and the user status using known algorithm. So transaction will be validated whether using the known algorithms, whether the transaction is being performed or not. Then a verified transactions can involve cryptocurrencies, contract records, and other information. So we'll discuss in this about contracts, records, another thing. So cryptocurrency. So this one you understand. So on blockchain we cannot we usually transact using cryptocurrency. So cryptocurrency can be, as you have heard of, it can be anyone. There are many existing in the market like Bitcoin, Ripple, Ethereum, and many more are there in the market. So any cryptocurrency can be used to perform the transaction on the blockchain. So it says a verified transaction can involve cryptocurrency contracts. Contracts, it means to say smart contracts. Smart contracts, they ensures quality of service, and smart contracts are something, they are just conditions that gets automatically triggered uh, as and when required. So contracts, they basically remove the involvement of any human interference in respect to quality of service, because these days, right now, suppose contracts are very important. Suppose some terms and condition or some quality of services are being compromised, then service provider needs to pay penalty for that. So with the help of a smart contract, so there is no human intervention in that, and this condition, this contract will automatically triggered, and service provider will be charged for bad quality of service. So it behaves in both the ways, as it is a predefined, or you can say as it is a coded set of instructions are there. So it get automatically triggered, and when a condition is fulfilled. So it can be a bad quality of service, so service provider will be penalized, or some other contracts conditions can be there. So once a transaction is verified, then this verified transaction is combined with other transactions to create a new block of data for the ledger. So because in a block, it consists of 5 transactions, 6 transactions, 7 transactions, depending on the block size. So once that size is reached, so that block will be created with n number of transactions, and block will be added to the blockchain, and transaction is considered to be as completed. So again, the new block is added to the existing blockchain in a way that it is permanent and unalterable. So here also issues are involved, that who will mine the block, and who will add the block, and how to add the block to the blockchain. So this we will discuss in the upcoming slides. So this is how a blockchain looks like. So these are the blocks that consist of some transactions, some end transactions, and each block is connected with the previous block. So as we have discussed in the previous slide, so we have an attribute that contains the hash of the previous block. So this is how these blocks are being connected with each other. So this is just an image that shows you how the blocks are connected with the previous block, and it shows you the attributes that a block is containing: block ID, hash of previous block, transactions, and n number of transactions are there, then block number is there. So this is how it looks like. Now blockchain as a tree. So this is a state when multiple blockchains are formed, but only one of the blockchain is the longest blockchain, and that is the valid blockchain, and other blockchains are considered as invalidated blockchain. So it is a momentary scenario that will create some time, and we will have multiple blockchains instead of one blockchain. Okay, so but out of those multiple blockchains, only one blockchain will be the longest blockchain, and that blockchain will be considered as valid blockchain. So let's see when how this scenario will be created, or under what circumstances this scenario will be created. So suppose two miners found the knowns at the same time, then they will add the mined blocks, block number 2 and block number 3, to the previous block 1. So suppose two miners, two users are competing for a block, so and they solve the puzzle coincidentally at the same time. Okay, so two blocks will be created, one by each miner. So by miner 1, say suppose it is block number 2, and by miner 2 it is say block number 3. So previous existing block is block number 1, so we will add these block number 2 and 3 to that block number 1, but only one block at a time can be added to block number 1. It can be either block number 2, it can be either block number 3. Okay, so it is a coincidence that both of them have solved the puzzle at the same time and they get the chance to add the block. So it's a kind of tie here. Then again we have few other miners. Next miner mined the 3 blocks 4, 5, 6 and added them to the previous blocks they found 2 and 3. This process of mining continues and the block looks like a tree as shown. So this is how it looks like. So we have block number 1 that was previously existing. Then two miners at the same time mine this block. So one has mined block number 2 and another one has mined block number 3, but only one miner will get the chance to add the block to the longest blockchain. So suppose one miner added it to the blockchain, and now the second block, which is mined at the same time, will get invalidated. So it is shown in red. So and it will get back to the mining pool, and this block will be mined again. Then another we have 3 miners who have mined the block at the same time again. So other blocks will be considered as invalid blocks or orphan blocks, and they will not be added to the blockchain. So they will be sent back to the mining pool and they will be mined again. So this is what they mean by tree-like structure, blockchain as a tree. So these are nothing but the orphan blocks, and they are not the part of the blockchain, and they will be sent back to the mining pool and they will be mined again by the miners. Once mined by the miners, they can be added to the blockchain. So the longest chain is the accepted chain, which is in green color in the figure. Other blocks which are not the part of blockchain are orphan blocks. So these are orphan blocks. So these are few cryptocurrencies application using blockchain. So like Bitcoin, as you have all heard of this Bitcoin, this was released in 2009, the first decentralized ledger currency. Then we have Litecoin. It released in 2011, the first cryptocurrency that uses Cycrypt as the hashing algorithm. Then we have Bytecoin 2012. It focuses on user privacy through impassive and anonymous transaction. Then we have Peercoin. It was released in 2012. It uses proof of work and proof of stake functions. This we are going to discuss in the upcoming slides. Then we have Emercoin. It was released in 2013. So similarly, we have Ripple, Waves, Omni, and Gridcoin. So these are the few cryptocurrencies which are used to perform transaction on the blockchain. Then participants, moving on, we have blockchain layer. So this is quite interesting and important also. So here, as you can see, we have this meta application layer, consensus layer, and network layer. So network layer and application layer. So you must be very well aware of these layers. And consensus layers might be new to you. So because this plays an important role here in blockchain, this consensus mechanism. So we need to add a consensus layer here. And then we have a meta application layer at the top. So as you can see, that meta application layer, it consists of different application of this blockchain. So it shows that it can be used in voting, e-voting. It can be used in domain name services, escrowing, casino, then public key infrastructure, something like this. So you can see that it has a vast domain, and you can say varied domain. So the domains are totally independent of each other and quite different from each other. So you just name the domain and we'll let you know whether the blockchain can be used here or not. Then all the domains are not mentioned, like we can use in healthcare services, we can use in supply chain management, we can use in land revenue system, we can use in e-check banking system. So many other domains also exist. So this meta application layer, the functionalities of this meta application layer in the blockchain system is to provide an overlay on top of application layer to exploit semantic interpretation of blockchain system for other purposes and other application domain. For example, it has been experimented to adopt in multiple application domains such as decentralized naming system like Namecoin, decentralized immutable time-stamped hashed record, proof of existence, decentralized PKI such as Bitcoin. So these are few cryptocurrencies which make use of these domains, and so these are few domains which we have discussed here, and there are many other domains which also exist. Then we have application layer. So application layer defines the semantic interpretation of the blockchain system. So in application layer, we basically have cryptocurrency and smart contract. So cryptocurrency, as you know, it is used to perform the transaction between two parties on the blockchain. So this cryptocurrency plays a vital role here, and the transaction can be performed only with the help of these cryptocurrencies. So there exist many type of cryptocurrencies as we have discussed in the previous slides, and we can perform transaction using those cryptocurrencies depending on the parties who are performing the transaction, what type of cryptocurrency they accept. Then we have smart contracts. So smart contracts is very important. So this is something which I have discussed in the previous slide also. So smart contracts are really smart, and how they are, why they are smart, and why we are calling them smart. I will let you know. And contracts. Contract is something that is signed between two parties. So if it is signed using pen and paper, means if manual human intervention is there, so contracts are met sometime and they are ignored many times. So with the help of, when we make this contract smart, then there is a very less probability that the contracts are ignored. Contracts are ignored means you can say deadlines are overshooted, yeah, deadlines are not met, yeah, commitments are not made, yeah, because there is no any human intervention is not there. Everything is will be performed by the pre-coded set of instructions, because everything is coded with the help of program, and we have predefined set of instructions over there, and no human intervention is there. And it is for sure, if the contracts or commitments or the quality of service, the committed quality of service is not meet, so service provider will be penalized without any human intervention. So only the smart contracts will get triggered, and they will be charged accordingly, and users will be benefited. So that's why we are calling the contracts as a smart, because no human intervention is there, and uh, they will not be ignored anymore, as it is used to be many times when we are working uh, or committing just on piece of paper. So this is not a piece of paper, this is something more than that. So this is a pre-coded set of instructions, and without any human intervention it will get triggered, and service provider will be penalized accordingly if there is any compromise in the quality of service, committed quality of service. So this is where what a very good thing about blockchain. So an example of semantic interpretation would be to define a cryptocurrency, then set up protocol for how such a currency can be exchanged between different entities. So another example is to establish protocol to maintain a state machine embodying programming capabilities within the blockchain, which can be exploited to create and deploy immutable code, so-called smart contract. So these are the two examples, and which runs on application layer, and which provides support to the topmost layers. So this application also defines the rewarding mechanism, if any, in the blockchain system. So rewarding mechanism, by rewarding mechanism, we mean some kind of incentives, because blockchain is an open system. So any user can can start participating in the blockchain. So they can start acting as a miner, and they can start mining the nodes. So until and unless there is any kind of motivation for us, why would we show interest in something? So rewarding mechanism is a kind of motivation for the users, so that they can take part in blockchain, they can become the miner in blockchain, and it's a smooth functioning of that blockchain. So rewarding mechanism, it was started by Bitcoin only, because Bitcoin is the first cryptocurrency that was evolved, and there we use proof of work, and proof of work requires a lot of resources to solve that puzzle when the miners are competing for adding a block in the blockchain. So we need to have some rewarding mechanism for that one. So the miner who solve the puzzle first will be rewarded accordingly. But over the time, this rewarding mechanism get changed, and it is no more same as we used to have in 2009. So now it's almost 11 years. So this rewarding mechanism has been diluted as per the user requirement, or you can say with the increase in the number of user, or we can say the increase in the number of miners, this rewarding mechanism has changed. But it does not affect that thing does not affect the working of blockchain. Blockchain keeps working, and we have many other cryptocurrencies that does not use proof of work and that have their own consensus mechanism and own rewarding mechanism. So this is something about application layer. So moving to consensus layer. So this one is very important. So consensus layer and uh, is very important in this one. So the consensus layer as presented in the figure is responsible for providing the distributed consensus mechanism in the blockchain. So that essentially governs the order of blocks. So consensus, the dictionary meaning of consensus is you take the mutual agreement, you reach the mutual agreement with the consent of every other node in the network. So consensus is something like that that we are taking consent of every other node in the network. So this is what we mean by consensus. So suppose I am adding some block, or I am fighting for adding getting the block to be added to the blockchain. So if I have validated some transaction and I am ready to add that block to the blockchain, then I need to take the consensus of every other miner who is mining the block in the blockchain. If I get the consent from all the miners, then I am ready to add that block in the blockchain. But without consent, without mutual agreement of all the miners in the blockchain, I am not able to add that block in the blockchain. So this is something important, and I'm going to discuss in brief about these consensus algorithm. And there exist a lot of consensus mechanisms, and it's a topic of research, a hot topic of research these days in blockchain, that how to propose a consensus mechanism. So it is a kind of you can say you can depending on the requirement, application requirement, we can keep changing the consensus mechanism. We will discuss in brief the type of consensus mechanism existing these days. So a critical component of this layer is the protocol, proof of work, and proof of stake. So that is used to verify every single block, which ultimately is used to achieve the required consensus in the system. So proof of work was first started by the Bitcoin. So there we used to have computation specific puzzles. So that needs a huge set of resources. You can say huge set of computational resources. With the help of GPU or with the help of TPU servers, only those puzzles can be solved efficiently. And right now, this proof of work was mainly used by this computation specific proof of work was mainly used by Bitcoin, and other consensus mechanisms also exist where this computation specific proof of work is generally not used, because everyone miners like you and me cannot take part in that proof of work, which needs high computation resources, because we don't have such high computation resources available with us. If you have high-end GPU servers, high-end TPU servers, then only you can take part in that computation specific puzzles. Only then you can win those puzzles, and you can add that block in the blockchain. So it is very much computation specific, but other consensus mechanisms also exist. So they have their own consensus mechanism, and that does not require this computation specific proof of work. So it also depends on the type of application where or type of, you can say, whether we are working in public blockchain or we are working private blockchain. If we are working in private, yeah, permission blockchain, there is no requirement of such huge computation specific proof of work or consensus mechanism. Then also in permission blockchain we can work with a bit more diluted consensus mechanism that will also work fine, because every participant is known there in permission blockchain, but the case is not the same in permissionless blockchain or open blockchain. In open blockchain or public blockchain, the participants many times are unknown, and we need to enforce a strict consensus mechanism over there. So both have their own benefits and demerits. Then the bottom layer here is a network layer. The component in this network layer are responsible for handling network functionalities, which include joining in the underlying peer-to-peer network, remaining in the network by following underlying networking protocol, disseminating the current state of the blockchain to the newly joined nodes, propagating and receiving transactions and blocks, and so on. So everything is happening with the help of this network layer, where we have decentralized peer-to-peer network. So you understand, decentralized peer-to-peer network, even if one of the node gets down, our system will keep running. Okay, there is no single point of failure, and the services it is involved for, or it is responsible for, is to provide the blockchain and maintain its maintenance, and ensuring its consistency, and to ensure that every miner in the blockchain is having the updated copy of that block. And so these are the few services that are that should be maintained by a network layer, and it is happening in a decentralized peer-to-peer manner. So this is these are the four layers we are having in blockchain. So network layer, consensus layer, application layer, and meta application layer. So here we can have few more domain. We have just defined existing five domains here. Then in application layer, we have defined cryptocurrency and smart contracts. So cryptocurrencies are the medium, or a kind of currency, a kind of logical currency that is used to perform the transaction between two parties on the blockchain. And smart contracts, so these are the conditions that will get automatically triggered if the committed set of services is not rendered, or whenever the condition is met, these contracts will get triggered. Then we have consensus layer. In consensus layer, we have different consensus mechanism, and in the upcoming slides we'll discuss in brief about those consensus mechanisms and how they are important. And depending on the application requirement, we can change the consensus mechanism accordingly. And then we have network layer. Here we are maintaining a peer-to-peer, decentralized peer-to-peer system, and these system are responsible for maintaining the consistency of the blockchain and to provide the updated blockchain to the miner in the block. So this is these are the blockchain layers that are involved here in blockchain. So moving on, we are going to discuss now the actors that are involved in blockchain, or you can say the users, or a different kind of users that are involved here and that are responsible for making this blockchain work. So we have blockchain architect, we have blockchain developers, we have blockchain users, we have blockchain regulators, we have blockchain operators, we have blockchain membership services, traditional processing platform, traditional data sources. So blockchain architect, so these are responsible for the architecture and design of blockchain solution. So this means that they are the person. Suppose I am owning a private company and I want my work to move on to blockchain. So I need to make my requirement understand to some person who can collect the requirements and who can understand my requirement and who can start designing and developing the blockchain as per my requirement. So because I'm owning a company, so instead of going for a public blockchain, I will consider going for a private blockchain, because private blockchain for me will be easy to handle and easy to maintain. Okay, and because I have some set of users who will be accessing that blockchain and it won't be open for the public, so better going for public blockchain. I I'm more comfortable in managing a private blockchain, so that I can give I can give my requirements as per my company needs. And once the concerned person can collect my requirement, understand my requirement, he can start developing the blockchain accordingly. So we have blockchain architect for this purpose, who are responsible for the architecture and design of the blockchain solution. So they will collect the requirement from me, or from a private company or from a public company, and they will pass on this requirement and design to the blockchain developers. So blockchain developers are responsible for developing the application and smart contracts that interact with the blockchain and used by blockchain user. So to interact with the blockchain, we need an interface. So without interface, we can't interact. So for everything, we need an interface. Even if you want to access some services, like you want to perform a transaction using bank, so again a web interface is being provided to you, or a Android based application is being provided to you, and using that interface or using that application, web interface or Android based application, you can perform the transaction. So though it is something logical, you can't touch it and you can't feel it, so but it is an interface that you can visualize, and it can be a web interface, it can be an Android based interface. So the blockchain developer gets this purpose fulfilled for user. So they develop the applications by which we can interact with the blockchain, and they are also responsible for writing the smart contract. Writing the smart contract is very important, because if smart contracts are not there in place, then in case the set quality of service is not meet, the service provider can be penalized. Okay, if smart contracts are there, then only the service provider, in case of not providing the good quality of service, will be penalized without any human interaction or human interference. So this is a very good thing about blockchain, that is smart contracts. So these are the pre-coded set of instruction, and in case the quality of service is not meet, the service provider will penalize automatically. Then we have blockchain users. So blockchain users are like you and me, who are using the blockchain for making a transactions for a particular commodity. It can be anything, voting, it can be land revenue, it can be healthcare system, it can be anything, using some cryptocurrency. So business user operating in business network, this role interacts with the blockchain using an application, and they are not aware of the blockchain abstract. So this one is very important. You need to understand this abstract thing. So dear participants, so today I am abstract to you. So you must be wondering why I'm saying like this. So though I am visible to you, but you don't know where I am sitting, what is my location, what is my ID, what is my IP address, and you are just getting my voice. That is sufficient for you, and you are just able to access my screen that is visible to you. So my screen and my voice, that is sufficient for you. So I am abstract to you today. Okay, even if my face is not visible to you, that won't affect much. Okay, So abstract is a very beautiful concept in a distributed system. So wherever it is used, so it is very useful every time and everywhere wherever it is being used. So dear participants, you need to understand abstract. So by abstract, that something that is not required is hidden to you, and and everything that is required is visible to you, or you are getting the desired set of services. So today, in my session, what is required for you is my voice is and my screen. So both things are visible to you, and both things are screen is visible to you, and my voice is audible to you. So your purpose is getting fulfilled. ठीक है, इसके अलावा whatever other things are there, those things are irrelevant. ठीक है, they won't affect today's session. ठीक है, so this is a very beautiful concept. They are not aware of the blockchain. So similarly, when we are accessing the blockchain, you are not aware where that blockchain exactly happens. You leave blockchain, you take example of Google, you take example of Gmail, you take example of Facebook, which you are using in a day-to-day life. Okay, you don't know where that server of Facebook, Gmail, or Google is residing. What even we don't know what is the IP address from which we are getting the services from Google, Gmail, or Facebook, or Twitter, or LinkedIn. Okay, we are just happy, and we are just interested in whenever we type google.com, the page should come up and we can start surfing and we can start searching any stuff whatever we want, and our purposes get done. हम कभी भी we never look at we are not at all interested in the IP address. हम कभी भी उसका IP address में interested नहीं होते हैं कि what is the IP address of the server from which we are getting the services. Are we interested? Anytime we are interested? No, we are never interested. We are just interested in the desired set of services. ठीक है, हमें हमारा जो desired set of services है वो हमें मिल जाना चाहिए. That's it. We are only interested in that. So today, for this session, your desired set of services is my screen should be visible to you and my voice should be audible to you. So you are getting the desired set of services, and rest of the things are totally irrelevant to you, and you should not be bothered at all about those things. So abstraction is really a very beautiful concept that has been developed, or that exists in this real world. So we'll discuss more on this in the upcoming slides if required somewhere. Then we have blockchain regulators. The overall authority in the business network, specifically regulators, may require broad access to ledger contents. So sometimes you need to change as per the requirement. So for that, we have blockchain regulators. So in public blockchain, it's not easy to change the things, but in private blockchain, the thing will be as per your requirement, so they can get changed quite frequently as compared to the public blockchain. Then we have blockchain operator that manages and monitor the blockchain network. Each business in the network has a blockchain network operator. So it is a responsibility of blockchain operator to maintain and manage that blockchain. So network is basically, you understand that it should be a decentralized peer-to-peer network. Then we have membership services. So it manages the different type of certificate required to run a permissioned blockchain. So as we will discuss next steps in brief about the permission and permissionless blockchain. So these for a permission blockchain, because everyone cannot access the permission blockchain it acts as a private blockchain, and it is only accessible by a specific set of users. So whosoever are concerned or connected to or required to access that blockchain. For other people, it may be useful, may not be useful. So there is no point of being a part of private blockchain if it is useless for them. Then we have traditional processing platform, an existing computer system which may be used by a blockchain to augment processing. The system may also need to initiate requests on the blockchain. And then we have a traditional data sources, an existing database system which may provide data to influence the behavior of smart contracts. So these are the few actors which plays a vital role in blockchain. In the components in blockchain solution, we have ledger, we have smart contract, we have peer network, we have membership, we have events, system management, wallet, and system integration. So ledger, as you know, is a channel's chain and current state data which is maintained by each peer on the channel. So you can understand ledger as a book of records or as a ledger of records. So these records should be maintained, and the current state should be replicated to all the peers who are taking part in the blockchain. So as I have discussed in the previous slide, that if replicas are being maintained, then an issue that gets automatically associated is the issue of consistency. Because once a blockchain is modified, we need to propagate those modification or those changes to all the replicas of the blockchain wherever it is residing. So then we have smart contracts. So as I've told you earlier, it is nothing but a pre-coded set of instructions that will get automatically triggered if the committed set of services is not delivered. So it's a kind of software running on a ledger to encode assets and transaction instruction, business logic, which says in for modifying the assets. Then we have a peer network. So basically we are talking of decentralized peer-to-peer network, and on top of which we are running our blockchain. A broader team over reaching the entire transaction flow, which serves to generate an agreement on the order and to confirm the correctness of the set of transactions constituting the block. So this is they are discussing something about your consensus mechanism, where we need to reach the consensus to add a block to the blockchain, because multiple miners are mining the block at the same time, and to ensure that no two blocks coincides, we need to have some sort of puzzles or some mechanisms to ensure that at a time only one miner can add the block in the blockchain. Okay, so this is you can think of like in operating system you have that critical section issue, problem of critical section, and in cricket like you have ties. So tie should not be there, and even if it is there, so only one block at a time will be added to the blockchain, and other block will be considered as orphan block. It will be sent back to the mining pool. It will be mined again. So we try to overcome those problems with the help of consensus mechanism that we implement in our blockchain depending on our application requirement. So then we have membership services, authenticates, authorizes, and manages identities on permission blockchain network. So as in permission blockchain, every participant is known. So so they are means we have only authorized user who can access that blockchain, permission blockchain, and in public blockchain we have anonymous user. We don't know their identity, and we have n number of users over there. So yeah, so membership is basically something that is required for permission blockchain, and it is comparatively bit easy to manage a permission blockchain as compared to private open public blockchain. So then we have events that create notification of significant operations on the blockchain. Example, a new block is created, as well as the notification related to smart contract. So this is like a kind of pop-ups you will keep getting when you have new message in your inbox, new message on your WhatsApp, new message in your mailbox or SMS. So even so this you will get a pop-ups or you will get notifications, so that you can check if it is related to you when a new block is added. So you can look at your transaction where if you have one in that new block. and it is related to smart contract also. So whenever the some condition is met, or so the smart contract will get automatically triggered, and either the user will be benefited, or service provider may be penalized sometimes. Then we have system management. So it provides the ability to create, change, and monitor blockchain components. So sometime or other, we need to uh, perform these operations to create or to change or to monitor the blockchain components. Then we have wallet. Securely manages user security credentials. So wallets, they play an important role. So you must have heard of cryptocurrencies, as I have also discussed the same in the previous slides. So have you ever think of where you will store these cryptocurrencies? So it can't be stored in your physical wallets you having these days. And how it looks like. Have you ever bothered to think that can we touch and feel cryptocurrencies? Have any one of you ever tried to touch and feel cryptocurrency? Because it's a logical currency, or you can say it's a logical money. It's just consists of comprises of some keys. Okay, it will be a long key of 1,000 characters or something. So so the wallets, you can only use some logical wallets, or you can use your pen drives, USB drives, to store those cryptocurrencies. Or you can have we are having these payment wallets these days. So we can have some specialized cryptocurrencies wallet. Maybe these apps which are providing these payment apps may start providing cryptocurrency wallets. So we have specialized cryptocurrency wallets that use to store your cryptocurrencies. So cryptocurrencies can't be stored in your physical wallets that you are using today for storing your currencies. So we have specialized wallets through which you can make the payment to the blockchain, through which you can where you can store your cryptocurrencies. You can also store your cryptocurrencies in your USB pen drive, but they are not assumed to be safe, because if you lost your pen drive, so and you don't have any other replica of your cryptocurrency, then your money is lost. So wallets are something that plays an important role here, because it is not something you can touch and feel like your physical currency you can touch and feel. So cryptocurrency is not like that. Then we have last one as system integration. They're responsible for integrating blockchain bidirectionally with external system, not part of blockchain but used with it. So, and one more thing I want to discuss, that these days you are seeing that we have make the wallets, your existing payment wallets are interoperable. Means you need to just you can use just one app for making payment to any QR code. So it is not like this. Earlier it was like this, that Paytm QR code can be only payable via Paytm app. So but now these days you can use any payment app to make payment to any app, like Paytm, Phone Pay, Amazon Pay. So interoperability is there. And uh, uh, means any app can be used for paying to any other app. So integration is required. So here we need to integrate many things, like from the same app we can access the blockchain, and from the same app we can in the same app we can store our cryptocurrencies, and from the same app we are able to pay the make the payment using cryptocurrency on the blockchain. So until and unless there is a kind of integration where the we won't be able to uh, make use of that very efficiently. So integration is very important. So integration of different things should be there, like accessing the blockchain, like storing the cryptocurrency in our wallet, and like making the payment to the using the cryptocurrency over the blockchain. Then few other set of services also required, like we can search our transaction, we can validate our transaction, and few more things should be there. So system integration plays an important role over here. So we'll discuss a few things about ledger and how it looks like, and how we use this ledger to interact. So a ledger consists of two data structures, a blockchain and a word state. So blockchain is a linked list of blocks or hash chain. Each block describes a set of transactions, and it is immutable. Blocks cannot be tampered. This is what we have discussed. So this is all you understand, that blockchain is nothing but a linked list of blocks. Okay, so and each block contains some transactions. So some end transactions will be there depending on the size of the blocks, and these end transaction can be of same domain and can be of different domain. And once a block is added to the blockchain, so you can validate your transaction or search your transaction on the blockchain. And blockchains are immutable, means it cannot be tampered, it cannot be altered, and even if you try to tamper or alter that blockchain, it will get invalidated. Then the second thing we have here is word state. So this may be some of, in the previous session you must have discussed these things, word state and blockchain. So it stores the most recent state of the smart contract, the output of transactions. It's stored in a traditional database, and data elements can be deleted, added, modified. So this is the word state. So this is what a ledger looks like. So we have transaction and we have word state over there. So word state is kind of a database, and it is stored in a traditional database, so where the elements can be added, modified, or deleted. So how the application interacts with ledger. So this, though we have already discussed, so with the help of some interface, we need to have one interface that is being developed by a developer like you and me, and they develop the client application and smart contracts. So client application will do the following. It will invoke the function written in the smart contract, use the development kit to submit a transaction on the blockchain, and access the blockchain to see the committed transaction and the history of transaction. So we will have some client application that is developed by the blockchain developer. So blockchain developer develops the client application, and using that client application, we can access this blockchain, and we can access the ledger, and we can see the history of all the transaction, whatever is being done by us. And it also developed the smart contract. So it records all the transactions on the blockchain and record the modified data element on the word state for every get, put, and delete blockchain to see the committed transaction history of transactions. So with the help of these client application that are being developed by the blockchain developer, we can access that blockchain, and those smart contracts are also developed by these blockchain developers to trigger the condition if the committed set of services are not delivered by the service provider, and the service provider can be penalized accordingly with the help of these smart contracts. So this is something same thing which I have discussed. So how the application interacts with the ledger. So in every peer-to-peer network, we perform the above functions. Whenever client application submits data to smart contract, the contract is executed on all the peers, and all nodes update their word state simultaneously. Then they will agree that the output is valid and consistent. After that, blocks get added in the blockchain. So once the consensus is achieved, the block will be added to the blockchain. So unlike Bitcoin, there will not be any forks or orphan blocks in the permission blockchain, because Bitcoin is uses a public blockchain, and there are chances of orphan blocks being generated in public blockchain. So, but in the permission blockchain, there won't be any case like this. So, in permission blockchain, the consensus mechanism will ensure that at a time they only mine one block at a time, and that block will be added to the blockchain because it is permissioned or private blockchain. So, an event can be emitted whenever a block is committed or rejected. A function is invoked, disk is full. So these are the few events and that will be triggered. So event emission depends on internal processing of the organization or asynchronous processing system. And this is how the application interacts with the ledger. So moving on to blockchain types. So I was discussing in my previous slide something about means couple of times I've used this permissioned or permissionless blockchain. So you must be wondering what exactly is permission and permissionless blockchain. So we'll be discussing these things. So depending on the application domain, blockchain deployment strategies can be pursued. Based on these strategies, there are predominantly two types of blockchain, namely public blockchain and private blockchain. So public blockchain sometimes are also considered as permissionless blockchain, and private blockchain are also considered as permissioned blockchain. So another way of describing public-private might be permissionless versus permission, or pseudonymous versus identified participants. So we usually have identified participants in the permission blockchain, and we usually have pseudo-anonymous participants in the public blockchain and identified participant in the private blockchain. So there is a big difference in what technologies you need depending on whether you allow anyone to write to your blockchain or non-vetted participants. So it depends totally on your requirement, whether you want to go for a public blockchain or you want to go for a private blockchain. Because public blockchain, the changes will not be as per your requirement. You have to change yourself as per their requirement in public blockchain. Okay, whereas in private blockchain, it will be a fully customized blockchain as per your needs, as per your requirement. Nowadays, many big players like Microsoft Azure and many more, IBM, they are providing customized blockchain as per your requirement. Means they are providing blockchain as a service. They start providing blockchain as a service, and you just have to tell them your requirements, and they will customize the blockchain as per your requirement. So Bitcoin in theory allows anyone to write in its ledger because it uses a public blockchain, and anyone can access that Bitcoin, that blockchain. But in practice, only about 20 people a group actually do. So, and it's not easy to maintain a public blockchain because the data over there is very huge, very large, and as compared to private blockchain, it's quite easy to maintain. So a public blockchain, also known as unpermissioned or permissionless blockchain, allows anyone to participate in the blockchain to create and validate blocks. So people like you and me can also take part in or can also start acting as a miners, can also start mining the blocks in public blockchain. So I'm not saying that in Bitcoin, because the consensus protocol used by Bitcoin is requires huge resources, as well as to modify the chain state by storing and updating data through transaction among participating entities. This means that a blockchain state and its transaction along with the data stored is transparent and accessible to everyone. So means the transaction performed on the blockchain. Once the block is added to the blockchain, the information can be accessed by anyone and the data will be transparent. So again, I want to tell you something about transparent. So transparency here is only the desired things are visible or accessible to you. The things which are not desired, they are hidden to you or they are abstract to you. So this is again that transparency uses the concept of abstraction. So transparent is something desired features are visible to you or accessible to you, and the features that are not desirable should be hidden from you, should be abstract from you. So this raises privacy concern for particular scenario where the privacy of such data needs to be preserved. So sometimes if you are working on medical records or if you are working on some other sensitive data, so there you need to preserve the privacy of that record. So for that purpose, the best way is to go for a private blockchain or permission blockchain instead of going for storing the records on a public blockchain. So in public blockchain, results can be public in two senses. Anyone without permission granted by another authority can write the data, and anyone without permission granted by another authority can read the data. So, dear participants, so in this point, the second point which says that anyone without permission granted by another authority can read the data. So as long as someone is reading the data, it's fine. So means if someone is reading the data, it is not creating any kind of overhead on the blockchain. Though it, if some sensitive data is being read by unauthorized person or the person who has unfair intentions can make use of that data to infer or to find some pattern in the data, and he can make use in some different way or to harm the system. But this is something about reading data is not creating any kind of overhead over the blockchain. Okay, though if you want some person to be restricted or some only the selective person to read that data, then you have to go for the private blockchain. But in this public blockchain, this point, anyone without the permission granted by the another authority can write the data. So dear participant, this writing of data on the blockchain is will create the overhead, because if we are writing something on the blockchain, those blockchain is being modified, and those modification needs to be propagated. So the propagation of those modification, it depends on the requirement of the application. It can be immediately propagated, it can be lazily propagated, and it can be propagated on demand also. So there are many ways to propagate those changes that are being done on the blockchain depending on the application requirement. So if my application requirement is very critical and I want all the changes immediately, so I will go for the immediate updation. If my blockchain applications are not critical, so I will go for lazy updation. And if my changes depends on the demand, demand means if I access that set of services, only then I will update my blockchain. So I can go for on-demand updation of blockchain. So means writing data again, because we are working on different replicas of this, we have created different replicas of this blockchain. So whenever we write something on the blockchain, the issue of consistency get associated here. So with this issue of consistency, if we need to handle this consistency issue very wisely. So this writing data will create overhead on the blockchain, and this should be done or very wisely. Usually when people talk about public blockchain, they mean anyone can write, because Bitcoin is designed as anyone can write blockchain where participants are not vetted, because it is a public and open blockchain. So the participants are also anonymous over there, and we are not aware of the participants, so they can hide their identity. So this sometimes can create overhead, because we cannot restrict the participants over here, and every participant is free to join this blockchain. So and we have ve- kind of participants over there with fair intentions also, with unfair intentions also, and so we can't control them. We don't have any control over there in public blockchain. We can add to the ledger without needing approval. It needs a way of arbitrating discrepancies with no boss to decide. Where defense mechanism against attack, anyone can misbehave with relative impunity if there is a financial incentives to do so. Because I can bribe someone to congest the blockchain. I can bribe someone to create overhead on the blockchain. So I can bribe someone to inject denial of services in blockchain, something like this. So these create a cost and complexity to run this blockchain. So means though if there is an advantage of public blockchain, automatically it get associated some disadvantages also. So the cost and complexity on running this blockchain is quite huge. So as compared to this one, we have a private blockchain. So private blockchain are also known as permission blockchain. So it has a restrictive notion in comparison to its public counterpart, in the sense that only authorized and trusted entities can participate in the activities within the blockchain. So here the participants will be known to everyone, and there won't be any anonymous participant here. By allowing only authorized entities to participate in activities within the blockchain, a private blockchain can ensure the privacy of chain which might be desirable in some use cases. So again, if I have my own company, so it will be good for me if I go for a private blockchain instead of public blockchain. And in that private blockchain, I will give access only to authorized user. Like financial services are there in my company, so I will give access of financial service only to the accounts person. I will not give access for the financial service to all other users or all other employees who are not related to financial services. So I can segregate those set of users who can access the services. So this will ensure that the uh, the authorization, and ensure that no unauthorized person is accessing the desired set of services. Only authorized person is able to access the desired set of services. So private blockchain, conversely, a private blockchain network is where the participants are known and trusted. So like in industry and a group of companies owned by umbrella company, many of the mechanisms are not needed. So this is very important, because many of the, you can say, complex mechanisms are not needed in a private blockchain, or rather they are replaced with legal contracts. So you will behave because you have signed a piece of paper. So means we are bound to behave in a very fair manner or in a very parliamentary manner, because we have signed a contract with them in private blockchain. So this changes the technical decision as to which bricks are used to build a solution. So and this makes this private blockchain very attracting and very much easy to maintain, because there won't be any anonymous user here. All participants are vetted and known participants, and all are bound to behave in a parliamentary manner as per their contracts they have signed. So basically, these type of private blockchain are being used by industries or a group of companies owned by some umbrella company. And here we need not to bother, or we need not to implement a strict consensus mechanism protocol. We can dilute those protocol, or we can use the light-weighted protocol over there to ensure that consensus can be reached quite easily without any need of huge resources or huge computational resources. So next we have this public versus private block. We will continue on this one, and let's take some break, and we'll meet at 12 participants again. So you can have some water and you can relax for some time. So we'll meet again at 12.
Okay, so thank you, sir.
Thank you,
So
sir.
in afternoon session, so from 12 noon, okay, so all the participants take some snacks, tea, water, and then after that come back again. We will meet at 12 o'clock. Thank you.